Hello everybody and welcome back, and right now let us actually start off by coding the part of persistence of our backdoor. So first thing we want to do is import two libraries into our reverse shell. The first library is actually the OS library, so we already used it before. As I showed you in the Python basics, if you want to clear your screen, for example, you need to import the OS library. So just go to the upper part of your reverse shell.py program and import OS. The next thing you want to import is import shuttle. Now this is the library where we will use the function which allows us to self-copy the file that we are running into a different directory. So that is also something that we want to import. And the third thing you want to import is the sys library. So import sys. Now we will need the sys library in order to use the shuttle.copy file function and in order to copy our file into the different executable. Now I'll show you what I mean, so just for now on import these three libraries and let us scroll down to the beginning of our program. Now where you want to code this is right at the beginning of it, so we want to perform this type of the self-copying file and creating registry key even before we actually perform the connection function. So what we want to do is make a variable called location for now on. So location equals, what we will do right now is we will set up a location where to self-copy or to basically make a copy of our backdoor to which directory. So we will use the app data directory. The reason why we are using the app data, or however you want to call it, directory, is because it is a hidden directory that most of the users can't even find. So in order for you to go to it, you just basically open your command prompt, make sure you are on your account, don't be on desktop or somewhere like that, just back out to your account directory, and then you can just cd to app data, and there you have three other directories, which is local, local, low, and roaming. Now we will be copying our file into the roaming directory, which is also a hidden directory. Oops. So cd roaming, and right here we will have our file. So this is the directory. Let me just show you a little bit better, where we will be copying the file. So this will be our location of our copied backdoor. So let us start coding that. Now the OS library allows us to actually specify this path on any PC we run this. So this means that, for example, you will not know how your target account is called, so you will not be able to actually specify the path itself into your code. You will need to specify the function which allows us to actually change that part of the account on any PC that we run this on. Now what I mean by that is that whoever runs this on their Windows PC, we will be able to execute this function, since the os.environ and then open brackets app data will itself bring us back the path to that folder, to that roaming folder. So what all we have to do right now for the location is we want to add the name of our file. Now you do not need to name the file the same as the file that you will compile. Let me just find this type of slash, so not the backward slash. You want to slash the forward, you want to use the forward slash, type 2 slashes, and then you will type the name of your file. You can name it anything you want, so we can name it backdoor, so we know that it is our backdoor. Of course, if you're running this on a real target, don't name it backdoor, it will be too obvious, and all you have to do is add .exe. Now this file right here, once you close the double quotes, will create a location, or basically will pass a path to the location of roaming with our backdoor.exe. So after we copy, if we type there in the same directory that we typed there before, we will have backdoor.exe in this directory right here. And you will also have the backdoor.exe in your directory right here, just this path right here will be different. This will be the name of your Windows 10 account, but everything else will be the same. So right now that we created the location, we want to actually perform the copying of our file. So how we do that? We actually do that with the shuttle. So shuttle dot copy file, and let me just make a space so you can actually separate this part of code from this. So shuttle.copy file is the function that we will use, and what we will use is sys.executable, comma, location. This function right here will perform the copying of our executable, which is our reverse shell, to the location that we specified under this name. So for example, if our executable after we compile it is called reverse.exe and they run it, put it on desktop and run it, it will make a copy right away of that same program to the app data roaming folder with the name backdoor.exe. And only after that it will perform the connection. So what we want to do right after this is basically perform the creation of the registry key for our file, so it can actually be run every time the user starts their computer and logs into their Windows user account. So we will use a subprocess library that we already imported, since we can see right here that we use the subprocess library for a different type of thing. Right now we want to type here subprocess.call, and we want to call the command that will actually make a registry key. Now this is the command that you can run in the command prompt, so we will specify the same command to the same path where we want to store our registry key. So we want to type here reg add. Now what I'm typing right here is basically just the syntax for adding the registry key, so just follow up with me. So reg add HKCU. Now this HKCU basically stands for this H key current user. So we are specifying the path right now, so we want to type a / and then software. I believe first of all it is software, right? So H key software, and then Microsoft, so /Microsoft / Microsoft, and then / once again, and let's see what's next. So after the Microsoft, the next thing is Windows, and then after the Windows we want to specify the current version, so /Windows and then / current version. And then I believe the next one will be run, so all we have to specify is one more, which is the run folder right here, where we will store our registry key, so /run. And right after that what we want to do is perform the /, so v, this will be the name of our registry key. We can name it backdoor as well, so let's name it backdoor. This is the type, so reg_cz, as we can see right here. This is what we specify with the name of the registry key, so we will have a backdoor name right here, and the type will be the same as other types as well, so registry_sz. And right now what we want to specify afterwards is the data part, or basically the part where we specify the path to our backdoor that we self-copied into the app data roaming folder. So let us do that as well. We have to do it with the /d command, and then what we want to specify is actually the double quotes. Why we are specifying the double quotes is because right now we will add a string to this command. If we specify just a single quote, it will make already our string, it will already close up our first apostrophe right here, so we do not want to do that. We want to add the double quotes right now, and then a single quote which will close this apostrophe. Then we want to add a plus location, which is the location of our path, so location, and then plus single quote, double quote, and then single quote. What we did with this is basically right here, as you can see, we had to use a mixture of the single and double quotes in order to specify the command correctly. So all we have to do right now is type here comma and then shell equals true. close our brackets, and that should be it. Now shell equals true is the same as in this part right here, so we can see we also use the same subprocess library. And right now, if we run this on target PC, it should create a registry key called backdoor with the type reg_sz with the location to the backdoor.exe file that we copied in our app data folder. So there is another thing that we need to do before we actually compile this and run it. What we want to do is actually test if this location already exists. So for example, let's say you run this a first time on target PC and they create, and then all the part of this code happens. So we copy the file to the app data and then we add the registry key. But let's say they restart the PC once again, and they will perform the same function once again. So they will add another registry key, they will perform the same part right here with copying the file. We do not want to do that. We want to only do that the first time they run the program. There is really no point in doing this once again after every reboot and after every time they run the program. So what we want to do is, after the specifying of the location, since this is a variable, we do not need to put it right here, we will use something called if not. Now if not is basically same as if, just right now we will specify if this path right here doesn't exist, this means that the program is being run for the first time. Since if this path exists, that means that the program has already been run before and the program has executed these two functions since this path does exist. But if it doesn't exist, which we will check with the function os.path.exists, and then we want to specify what path, which is the location path. Whoops. And then we put the two dots right here. And then if the path doesn't exist, it means we're running it for the first time. So we want to perform the copying to the app data folder, and we want to perform the adding of our registry key. If it does exist, it will just skip this code right here and it will go straight to the creation of socket and then performing the connection. So let's see how this will work if we just save this right now. Control O to save, enter, Control X to exit, and let's perform the compilation once again. Let me just find the command from the previous video. Here it is. So wine root and then the path to the py installer reverse shell.py, one file and no console. I click here enter so we can compile our program. We wait for the compilation to finish, and then after it finishes we will copy it once again. So let's add our USB drive. I first have to delete the previous reverse shell from this folder, so let me just delete this right here. So I have to open in terminal and I will remove the reverse shell.exe from the previous video. Good, so right now I can close this as well. Right now we want to go to our this directory right here. Oops. And we want to move as usual our reverse shell.exe to media, root, and then the name of your USB drive. We copy it there, and then we can delete all of the unnecessary things, so such as dist, build, and spec. So what we want to do right now is the same as before. So unplug the USB drive, open it on your Windows machine, paste the reverse shell onto the desktop, and then run the reverse shell. Now right now you can see that it is running the reverse shell, so everything went good. Now we can start up our server and listen for the incoming connections. Now since we know that our reverse shell tries to connect every 20 seconds, we should be good to go in about 20 seconds or less. As we can see, we already performed the connection and everything looks the same, but right now what we want to check is if the self-copying of the file worked, and also if we successfully created the registry key for that file. So right now if I go to the command prompt, we can see I'm still in the same directory. There is no backdoor.exe right here since I ran this dir command before actually running the program. And if I type dir once again right here, right now you will see we have a new file in here called backdoor.exe, which is the same size as our reverse shell. Since it is the same file, we just copied it into this directory. But also we want to make sure that the registry key is successfully created for this path right here. So if we go right here, press F5 to refresh, we can see a new registry key has been added, which is called backdoor, which is points to the path of the user's app data roaming and then backdoor.exe. So right now we know that this works successfully. Now every time the user reboots their machine, their backdoor will run at the startup or at the login of their account, and they will perform the connection every 20 seconds. So this means that we can successfully connect to their PC whenever we want, after as many times as they reboot the file. So right now, if they, for example, let's quit this, and if they, for example, even delete this reverse shell right here, which for some reason once again doesn't want to delete, so we will have to fix that as well. So let us close it in our task manager. They, for example, notice that this reverse shell didn't open anything, and they think this is a broken program. They delete it right here, and then they think they're good to go. So, but we know that we still have the backdoor.exe in our roaming folder, and that we also have the registry key for it to run at the startup. So now we will be able to connect even after they reboot and delete the file. So that would be about it for this video. I hope you enjoyed it, and I hope I see you in the next one. Bye! Hello everybody and welcome back. And right now let us continue on fixing and adding a different functions to our backdoor. So first thing you might have noticed in the previous videos, or in the first video where we tried to actually run our backdoor, you might have noticed that we can't really change our directory, so we can't go one directory back or forward, or basically change to any other directory instead of the directory that we ran the program in. So we want to be able to change that, and how we do that? Well, basically, first of all, let us nano the reverse shell.py. So let's see what we have to do in order to get this to work. So first of all, we want to go to our shell function right here, so let us tap this a little bit down, and we can see right now we have these two options right here, Q for breaking and try and accept rule, with basically executing the system commands on target system. We want to add another option right here, and we also covered in the Python basics that we can run an if-else command with multiple statements with using elif. So we will, after the Q, specify the elif command, and right now we want to specify basically what to do if we try to change the directory. So in our reverse shell, let's think first what the target or what the reverse shell will receive once we try to change the directory. We know that in Windows, if I go my command prompt, it is same as in the Linux, we can change the directory with the cd. So cd desktop will change the directory to desktop. We can see that we have three spaces right here. First two take these two characters, which is cd, and then the third space right here is the empty space. So we know that first we specify the cd command, which is two letters, and then we add space and then specify the path to the directory that we want to change. So we need to keep that in mind once we write this. So the target machine or the reverse shell will receive a command that will always start with cd, empty space, and then the path. So what we want to do is basically just select here else if command equals, so double quote, equals to the cd, close the quotes, and right here we cannot specify if the command equals to that. We need to specify if two letters of the command equal to cd, first two letters or first two characters. Now we know that we actually covered in Python basics the string manipulation, so we know that we can select the first two letters with typing 2 dots and then 2. This will only select the first two characters from 0, or basically character labeled as number 0 and character labeled as number 1. So all the characters up to the second one. and we know that it starts from 0, so 0 and 1 are actually first two characters. So here we specified if the command, if the first two characters of the command equal CD. We also want to specify and the length of the command is bigger than 1. Now this means that if the length of the command is larger than 2 letters, so for example if I just type here CD, you can see that the CD command in Windows actually prints my current working directory. It is same as pwd in Linux. In Windows it is just CD. So we want to differentiate these two commands, so CD, which prints the working directory, and CD to another directory, which is for example desktop. So that's why I specify right here, if the command, if the first two letters of the command equal CD and the length of the command is bigger than 1, this means that we want to change our directory to some other path, since we specified an empty space after the CD. And we want to add the 2 dots right here, and all we want to do is write a try and except rule right here. So we actually, if for example we run this on target and we wrongly specify the path that we want to change our directory to, this program will break if we do not have a try and except rule. So we want to try to change our directory, and we will try it with the os.chdir, and then the will be actually the command the command after the first 3 letters. And what the path to the directory will be is the command just after the first 3 characters. So command, then we specify these brackets right here, and then 3 and then 2 dots after the 3. We close these brackets and we close the second bracket. This means that the path that this function right here will try to change its path to the remaining of the command right after the first 3 characters, and we know that the first 3 characters are CD and then empty space, so after that will be the path. So we know that we will change the path to that part of the command. And we want to accept in case that directory doesn't exist, we want to send something back, so we will use reliable send. Or actually let's just continue right here. We do not want to use a reliable send since there is no point, so continue, which will actually just continue with our while true loop. So we specified right here to change our directory if the first 2 letters are CD and the length of the command is bigger than 1. And we also specified if that directory can be changed to, we want to specify the code to continue executing. So this should be about it for this reverse.py side part of code for the CD. Now we also want to specify what the server should do once the reverse shell basically execute the changing of directory command. So if you notice right here, right after we execute this command, we do not send anything to the server. So what the reliable shell will do, or pardon me, what the reverse shell will do after we execute the changing of directory, it will go back to the beginning of our true loop and it will try to receive the commands. And this will create a problem if we do not code the server part of the CD command as well, since the server will wait for the reply. And this both server and both backdoor will both be waiting for the replies at the same time, and that will terminate our connection and it will bug out. So we want to change the part of the server code as well. So save the reverse shell, ctrl-x to exit, and we want to nano our server.py. We want to go to the same part right here, which is the while true, and we want to add right here else if, and we basically what we want to add is same as in the previous code. So else if command first 2 letters equal CD, and the length of the command is bigger than 1, basically, same as in the reverse shell command, but right here we do not want to perform anything, we just want to continue. Now why do we want to continue? Well, we are the server, we are not really performing anything on our target, we just wanted to send the command for the changing of a directory to the target, and we want to go back to beginning of our while true loop where we can send the next command. So this is the entire part of the server code for the CD. So just save this and let us compile our reverse shell. We use the same command as before. I will just go backwards until I find it. So here it is. We use the same command, so just run it. This is something that we did already 3 times, so you should be already familiar with it. And all we want to do is just run and try to change our directory with our code in order to see if it works properly. So cd dist, we have our reverse shell right here. We want to open our USB drive. First of all, we want to change the directory to the USB drive. I'm not really sure why it doesn't want to change the directory there. Okay. And we want to delete the previous reverse shell. Let us go back to our dist folder and copy the reverse.shell to our USB drive. So just copy it there. And then you can do as usual by deleting all of these previous files that we created during the compilation. Right now, if we unplug our USB drive and we run the server and we copy this to the desktop, we double click and try to run it right now, we should be able to actually change our directory. So let's see if we receive the connection back on our target or from our server. We still didn't receive anything. That is because we need to wait 20 seconds before it tries first time to connect. So we should be getting the connection back any second. Here it is. And right now, first of all, we want to check out 2 commands. One of them is just cd, which actually allows us, if I just type here who am I, you can see it doesn't bug out. We get the CD and the shell back. And the next thing we want to check out is the changing of our directory. So we know that we are in the desktop directory since we are actually running the file from there. And if I type here dir, you can see we are in this directory. So what happens if we go one directory back? We want to type here dir once again, and you can see we managed to go one directory back and actually go to the user's directory. So let's go back to the desktop. There, so we are on desktop. Make directory called test. As we can see, we successfully made it. It's right here. And if we just change the directory to test and type here there, you can see we are currently in the test directory and there is nothing there since we didn't create any file there. So that would be about it for this tutorial. We managed to make our reverse shell or backdoor basically to be able to actually change the directory and not create an error while doing that. So right now we have almost a fully functioning reverse shell. What we want to do is basically also add the download and upload function, so we can actually download and upload files from the target system and also upload them to the target system. And that we will do in the next videos. So I hope I see you there and take care. Bye. Hello everybody and welcome back. And let us now add the download and upload function to our reverse shell. So let us actually first of all do our server, since last time we did first the reverse shell. So right now let us actually code the part of our server. We will have to add both of these functions in the both server and both reverse shell. So they will perform the separate tasks. So for example, if I send the download command, the target, that means that we want to get a file from the target, so the target will have to open that file and read its contents and send its content back to us, and we will have to write those contents that we receive back to a file on our own Kali Linux machine. That means the same, just reverse function for the upload command. So then we as a Kali Linux machine will have to read the file and send the file context back to the target PC, and target PC will have to write to a file that it will create on the target machine. So let us start off by coding it on our server. What we want to do is add another elif statement right here. So elif, and let's actually use a simple use of the command. So we will use just upload and download as the command for downloading the files. So in our server side, we will just have to specify download, set the empty space, and then the path to the file we want to download, or the name of the file. So let's start off with the download. So else if command that we specify, and let's count the letters of the download. So it has 8 letters. So if the first 8 letters of the command are download, which basically means this part right here, so equals download, then 2 dots, what our server wants to do is it wants to actually open the file with the same name as the file that we want to download, and we have to wait for the target to send us back the contents of the file that we want to download. And then that content that we receive, we will write to our file that we opened. So we will use a syntax for opening files, which is a little bit different than the one we covered in Python basics, but it is basically, it means the same. So with open, and what we want to open is the name of the file that we specify in the path. So with open command, and then the 9, and then onto the end of the command, which basically means, so let's say the command is, let me just type it right here. So let's say the command is download image.jpg, for example, or let's say text.txt. The first 8 letters, this will check if the first 8 letters of the command is download, then it will proceed with this command, and then it will open a file with the name from the 9th character. So first 8 are download, the 9th character is the empty space, and then from it will open a file with this name, which is what we want. So right now let us delete this and specify the name of the file. So with open from 9th character, we want to write to it. Since we are the server, we want to write to that file as soon as we receive its content. We can name it as file. So this is basically the same as this command right here. So file equals open command 9 from write b. This is the same command as this one. I just wanted to use this syntax to show you that you can use something like this as well. So you can use whatever you want. I will use this one. Now you might be asking, since we didn't cover, what is this WB? This B basically stands for bytes. Now why are we using bytes? Well, basically since we want to receive the contents of the file in bytes. So if we didn't specify this, we would, for example, only be able to download the text files, and we will not be able to download the executables, images, and other files. We want to be able, but we want to do that, so we want to be able to download any executable from target PC, any image for target PC, any song from target PC. That's why we specify right here WB. So we open it as file, that is the name of our variable, which we will, or basically or now of our file. And here we want to tab it in a little bit. And right now we want to receive actually the contents of the file. So we will just name it the same as here. We will name it the result the same as in the previous command. So let me just show you right here what we need to type. What we want to type is the same as this. So result equals reliable underscore receive. So what this will do is basically it will let us receive all the contents of the file, and those contents we want to write to a file. Now, in order for our file not to crash, we need to use a library called base64. The base64 library allows us to actually encode or decode the encoded base64 data and actually write it to a file. Now, I will show you what I mean. So first of all, file.write, type it right here. We know this command, we covered it. And then we want to use base64.b64 decode, and then we want to decode the result that we received, and then put the 2 brackets right here. Now you might be asking, why are we decoding something that we didn't even encode yet? Well, we will encode it in the part of the reverse shell code So basically in our reverse shell code, once we get the download function, we will actually first encode the data of our file and then send it to our server. Then the server will receive it, and then it will write the file that it will write the decoded data of our result. So this is basically everything we need to specify right now. Basically we can add the upload function right now, but before we do that, let us actually add the download function to our reverse shell, so you can compare these two, and then it will make a lot more sense to you. So we will open it like this, then we will open another window and enlarge it a little bit so we can make it this big. Go to our Python reverse and nano reverse shell. In the shell part, we want to basically perform a similar thing, so just go right here. Below the cd command, write another elif statement. The elif statement will be the same, so else if command from the to the 8th letter, so we want to specify to the 8th letter equals download. What we want to do then is basically right here we want to actually open the file since it is on target PC, and the reverse shell will also be a target PC. So what we want to do is basically just write with open brackets command, and then the same as right here as in the server code. But the difference right here is we want to open it for reading. Since it is our file, we want to read from it, then put the contents, then basically send the contents of the reading file to the server. So read bytes, and we open it same as file, so it makes more sense. We tab this in, and we want to reliable send the encoded data. What we will do is we will use base 64, and instead of base 64 decode, we use here base 64 encode. And what we want to send, we are sending the contents of the data which we can get with this function, so file.read, and then we close 3 brackets, or 2 brackets, let me just see. Yeah, we actually close 3 brackets right here. So let us compare these two so it can make actually more sense. First of all, let's go to the server. The server sends the download and then the path to some file, or basically the server sends download and then the name of some file. Then where the command gets sent to the reverse shell opens that file for reading, it reads its contents, it encodes the contents of that file and sends the contents back to the server. The server receives the contents of the file into this variable right here, and it has to decode the contents first before writing it to a file. So we use the function within a function, so this function in the brackets will get executed first, and then we will write the decoded result to our file. So simple as that. Let us save both. Let us save both of these. So Control O, and then right here also Control O. And what we want to do right now is also add the upload function. So we want to upload the files as well. Let's start off with the server. So let's add another elif statement, else if command, and then first 6 letters, since that's how much upload has, equals upload. What we want to do is basically, let me just find this. Okay, so we want to actually, what we want to do is we want to actually run a try and accept rule. Now while we are writing try and accept rule, is basically sometimes maybe some file won't be able to get downloaded or uploaded. So we want to actually, first of all, let us try to open that file. Since we are right now on the server, we want to open that file for reading so we can send its contents. So with open, and then we perform the same thing, so command, and then from 7th letter, the reason why we are using from 7th letter is because upload and empty space add to the 7, and everything after that will be the name of the file. And then reading, since we are right now on the server and we're uploading, we want to read this file. in bytes, and let's call it as fin. So this will be the name of our file. Then what we want to do is perform the same function as in the previous, so reliable send, and we want to encode the data, base64, b64 encode fin.read. Oops, I'm missing a bracket. Let me just enlarge this so you can see it a little bit better. So here it is. What we are doing is basically opening a file for reading and then sending its encoded data to there. Now, in order for us to actually be able to, let me just go to the back of this. In order for us to actually be able to know if the file was successfully downloaded, let's actually add something a little bit different right here. So let's add an accept rule. So accept, and we will actually add a variable called failed. And let's actually print that variable to be Windows. It doesn't even matter, just print anything you want in that variable so you know that it actually failed to download that file. So failed to upload, pardon me, not download, failed to upload. And we want to actually reliable send base64 .bit64 encode, and then we want to basically send the failed variable to the target, so failed. Now the reason why we're doing this is basically if you mistype a name of the file and then it will hang, it will basically break the connection, since it will try to open a file on your Kali Linux machine which doesn't even exist. So it will try to upload a file to the target system that you don't have in your directory, and it will hang on the connection and you will not be able to execute anything else. So we want to send this, and it will basically write on the target this, and we will know that the file failed to download, and then we can actually specify the correct name and delete the file that actually contains this string failed to download. Now, since we added this on the upload, since we added the upload function to the server, we want to also add the upload function to the reverse shell.py. So let us do the same. We want to add elif command from the sixth letter, so to the sixth letter equals upload. We want to open a file for writing, since we are receiving the contents. So with open command 7 from as writing bytes, as fin, so name it the same as in the server code so you can actually know to what it is referring to. It makes more sense. And what we want to do is basically result equals reliable receive. We are receiving the information of the file, and we want to write the decoded part of the file. So file write base64 b64, whoops, decode, and then the result is decoded, so result. So let me just check if this is it. Let's try to save it first. So here, let us check. We open a file for reading, and then we send its contents. Here we receive its contents, and then we write to the file the decoded content, so this should be good. If the file fails to open, or if we specify a wrong name to the file, it will write failed to upload to the file that we upload to the reverse shell. So let us see if this will work. We save both of these. I hope it works, so let us we do not need two terminals anymore. Let us enlarge this one and let us compile our program. So let's just search for the command. Here it is. We compile the reverse shell. And I just remembered that we actually add the base64 library to both of our programs. So we have to actually delete all of this. So delete it before we actually compile it again. And let's actually add it first to the reverse shell.py. We have to add the base64 library, so import base 64. We save. We also add the same to the server. Import base 64. Now let's see if we used another library that we need to import. I don't think so. We only use the base 64 library, so save, and right now we can compile it once again. And we should be good to go. While this is compiling, let us plug in our USB drive. And now let us copy the reverse shell to the USB drive. So ls move reverse shell to the media root USB drive. We move the shell and we delete everything else. We can run the server right away, listening for incoming connections. So we are listening, we unplug the USB drive and we open it in our Windows machine. Right now, let us copy the file and let us run the file. The file executed, and right now let's wait for a few seconds in order to receive the connection back. Now what we will try to do is we will try to download this image right here, which is the master ethical hacking. Let's rename it so we don't specify the entire name. Let's name it just hacking or hacking.jpg. And we can see if we are going to be able to successfully download this image from our target system. So here we have the shell opened, so let's see who am I, and let's type there to see the desktop. Here we have the hacking.jpg, and let's actually try to download, so let's use the function download hacking.jpg. If I press here enter, we can see that it executed normally, and let's see if we can actually still execute the command, so our shell is still running, and let's see where did we download our function, or pardon me, our image. So let's go to our files. We open our files, or let me just go to our places, not files, so places, computer. What path is that? That it should be in the root directory. And then we go to the Python files. Let me just find where they are. Python programs, reverse, and here we have the hacking.jpg image. We successfully were able to download it from the target PC. Now we do not need to download only the JPEG files. We can also try to create first the file on target PC. So let us clear the screen. Oop, CLS. Yeah, clearing screen is not the same as in the Linux. So let me just type once again. We are the desktop directory, and let us echo hello world into the test.txt. And we type here once again, and let us see if we actually echo the good thing. So test.txt, here it is, hello world. And now let's try to also download a text file. So download test.txt. It finished really fast. Right now we can delete the test.txt from our target since we don't need it there anymore. As we can see, we successfully deleted it with del test.txt. And right now, if I just close this and open the places once again, and I want to see if we successfully downloaded the text file as well. So let's go once again to the root, Python programs, and then reverse. Here's the test.txt, we open it, and in the test.txt we have a string hello world. So everything works fine with the download command. So we now know, let me just see why it bugged out. We now know that we can successfully download files from target PC, whether they are JPEG, PNG, text.exe, or basically any other file format. But right now what we want to check is if the upload function works as well. In order for us to upload a file, we need to specify, we need to make a file. So let us open another terminal. So let me just click right here, open a different terminal, enlarge this a little bit while our shell is running in the background, so cd python programs reverse. Make sure to have a file in the same directory as our reverse, or as our server that is running. So first of all, we want to delete this test.txt and hacking, since we don't need it on our directory right here. And let us nano a simple string file, so we will call it hello.txt. Oops, hello.txt. And here we will type, how is your day going? We will save it. We have here hello.txt. We can close this right now. And let us try to upload hello.txt. We press enter. We check if our shell is still running. It's running good. It executes the commands. We go to our desktop and we can see a file called hello.txt that we successfully uploaded. And it contains the string that we specified in our Kali Linux machine. Now, this file can also be either image or executable, or basically you can upload a different virus or malware or anything you want. With our reverse shell, it doesn't have to be a txt file, so let's delete it. And right now what we have is a fully working reverse shell that can upload, download commands, that has a persistence running, that has self-copied it, and then basically performs all the system commands and also performs the connection every 20 seconds. So we have a pretty good reverse shell for now, but we will also try to add some other functions as well to it. So that would be about it for this tutorial. I hope you enjoyed it, and I hope I see you in the next one. Bye!